we have been talking about crazy numbers, okay? And for those radicals, one more piece of those we need to talk about. It's a different kind of symbols. So they are rational exponents, okay? Let's see what do we mean by that. So we say crazy numbers, radicals, are opposite as the exponents, right? So we keep reviewing the property of exponents, okay? So we did this, right? AM times AN, same base. So how many A's there are? So n plus n, right? We will add the exponents. Then we call this product property. If for same base dividing, we put those exponents together, would be subtract, right? The exponent. Then we call them what? Quotient property when we do the divide. Same base, so we write it as one base with one power. If power on power, then we will multiply our exponent. Then we call this power property, right? Two powers instead. We wanted to write only one power for a single base. Then if you have two bases with one power, we write individually, you distribute, that would be what? AN to BN. So we distribute our powers. So we call this what? Power on a different thing, we call it power of a product. Right? If for a quotient, B to take nth power, you distribute will be what? AN over BNth power. Of course, B cannot be 0, right? So then when the quotient, right? When the quotient is raised to a power, then we distribute our power, right? We call it what? Power of a quotient, right? Then we also talk about what? A to the 0 power is what? Anything to the 0 power is 1. We don't use base as 0. We call this what? 0 exponent, right? Now we also talk about what? A to the negative n. Negative thing. It means what? Negative power, it means what? It's reciprocal, right? So then if 1 over A to the negative n power, that would be A to the n power, right? For the negative exponent. So we talk about positive exponent, negative exponent, right? So for the powers can be positive, can be negative, can be 0. What happens if they are fractions? So for fraction things, right, we call them what? Fraction number, we call them ratio. So for rational numbers, means what? Fractions. Right? Like 1/2, 2/3, things like this. What happens if our powers are fractions? Can we use the same rule? Definitely. Okay, so for the rational exponents On your right hand side on the top, right? So we are on the what? Page 47, section 9.8 for rational exponents. And if the power is a rational numbers, fractions, we still can use all the properties. Okay? So, let's take a look and review what we did before, because we say it's hard to look at the negative exponents. We always change your exponents to positive, write positively. Okay? So, if we have 2a negative 2c fourth to the negative 3, 2a fourth, a6, right? Then we want to consolidate all the same base, just one base with one power, okay? So to simplify this, what do? We will first remove parentheses, then you put all the same base into one, right? That's what we say, how to simplify. So there are many ways of doing it, but we can just remove parentheses by using all those properties. It's more straightforward, right? So for negative 3, you have how many bases inside? 3. So you do what? Distribute them, right? So you have 2 to the negative 3 power, a negative 2 to negative 3 power, c fourth to the negative 3 power, and time these 3 things, right? So we write it individually. Then 2 is negative 3, a is how many? Negative 2, and power on power. Power property, you multiply that 6. A 4 to the negative 3 would be negative 2 times 2, a fourth, a 6, right? Then we say we don't want to write the answers in the negative exponents. Then what does a negative exponent mean? Reciprocal. Then you need to flip. So this one you flip to 2/3, a6 stays, right? So 2/3, this is a negative, we need to flip. Then this a negative 12, it has to flip, right? Then 2 stays, a fourth, a6. Is that right? So 2 and 2/3, 2/3 power, and that would be second power, right? So how many a's on the top? 6, 4, and 6. Then we add our powers. That would be 16, right? 2 to the square is 4, and a 12. Then to clean up, what do we have? Where is my c? Oh, I was wondering. This one is c, right? I was wondering, where did the c go? So this one is the c. This one is the c, right? So that would be our answer, right? Okay, that's how we simplify. And it doesn't matter the power is the whole number, 0 positive or negative number. Even the fractions, we still use those properties same way. Okay, so let's look at the next one. 3x to the negative 2, 2xy negative 1 to the 0 power over 2x negative 2, y 3 to the negative 2 power. Then we just write it individually, right? 2 bases for the negative 2 power. So we have 3, negative 2, x negative 2, right? Then this one, it has 0 power. You can just write it individually, 0 power, or you can do it all together because anything to the 0 power is what? 1, right? You write it individually, still 1, 1, 1. You multiply 1, 1, 1, still 1, right? On the bottom, you have 3 bases and apply negative 2 to distribute. So negative 2 to the negative 2. Oops, that's 2. Base 2, not negative 2. Right? Is that right? Let me take a look. Okay, then x negative 2 to the negative 2, y 3 to the negative 2. So that would be 3 to the negative 2 power, x to the negative 2 power, right? Then you have 2 to the negative 2 power. For this x will be what? Negative 2 times negative 2 is 4. Y is 3 times negative 2 is negative 6, right? Then we need to flip those with negative exponents, right? So that's negative 2, so that's become 3, 2. This one, x is negative 2, becomes what? X squared, right? And this 2 is negative 2, so 2 to the square on the top. And this x fourth, not a negative power, so it stays where is it? Then this one, y negative 6 will be y 6, right? Then we cleaned up. 2 to the square is what? 4 and y 6, right? 3 to the square would be what? 9. Then you have 2 x's, have to put them into 1, so it's x, 2 and 4 power, that would be 6, right? That would be your answer for that. So we are reviewing what? All the exponents we did before with all those properties, right? Now we are going to talk about what happens if your power is a fraction. Okay, so we are going to talk about those rational exponents. Okay, excuse me. So let's see, what does the symbol mean? All right, so let's see some examples before we write the definitions. So when we write a to the 2/3 power, this one, same thing as your negative power thing. It's all symbols, okay? So this fraction doesn't mean fraction. The top one, the fraction numerator, means what? The power you will take for the base. Then 3 means what? The root you are going to take for the base. Okay? So if you do that, you will have what? A to the 2nd power, take the root, right? Or we say you can take a root first. Oops, root first, right? Cube root, then you take a power. Let's see, would they be the same? So a squared is 64, take a cube, actually is what? 4. And for this one, cube root of a is what? 2, take a square is 4. They will be the same. So you want to practice use calculator to do that, because you are going to use all those fraction style of exponents you need for pre-cal, calculus, and business calculus, right? So you need to do this. You put 8, that's your power, okay? Then you need to have a parenthesis, put the whole thing in, okay? 2/3 means what? 2 divided by 3. Do that on the calculator. You should get the same answer. Make sure you practice that, because when we go to calculus, we expect you know how to do it. Okay? So that's the number mean. When you put a to the 2/3 power, you should get a 4. Okay? So that's how we use the rational exponents, fractional exponent. Okay, so it will look like this. If we write a to the 1nth power, top is the power, bottom is the root, right? So that would be a take nth root, right? So when we have this situation, if n is even number, you make difference as odd number, right? Even root and odd root. So it might be even root or odd root. But when it's even root, then we have a restriction, because inside of the even roots, they have to be what? Positive or 0. Cannot be negative. That would be the restriction, okay, for the base. All right, to the 1nth power. If we write 1a to the m over n, it means what? It's the power, then take a root, or we can do what? We can do the root first, then take a power. They end up the same. Okay? Then same thing, if you have a fraction as an exponent, also you have a negative. They all are symbols. Okay, so you have to interpret the negative first. Negative means what? Reciprocal, right? That would be that. So then same restriction, if n is even, then a has to be bigger than or greater than 0, right? So that would be the concepts and definitions of the fractional exponents, right? So we call them what? Rational exponents. So you need this for your, pre-cal calculus. So let's look at the next page, page 48. Let's take a look at some numbers. Okay, so we can write it this way: 9/2 to the square. If we use power product, right? Mean power property, then you power on power, you multiply your power, then you end up, that's 1, you end up 9, right? Then if we use the meaning of the radicals for the power half, means what? Square root of 9, then you take a square, right? Then that will be square root of 9 is 3, take a square, you end up what? Still the same. So it means what? If they both take a square, it means what? The inside, actually, it means 9/2 power equals square root of 9. They are the same. Okay, so for math, we are just, being consistent everywhere. So however we use the symbols, you calculate them, you end up the same thing. Okay, but we say square root of 9, this symbol we only use as a positive. The root of 9, the roots of 9, you have 3, you have -3, both multiplied twice would be 9, right? But if you use this symbol, we only say it's what? Principal root. So if we want to have a positive or negative, we put it in outside. Okay? And same thing, we write what? Square root of 9, we just use 3, or 9 to the half power, we just use positive. Okay? If we write x as half power, it means what? Square root of x half. Only use the positive principal root. Okay? So inside of the even root, you have to be positive. We only use, we call it what? Principal root. We are not going to test you on those terms, but when we refer to it, you need to know what we are talking about, right? That's for square roots. How about for cube roots? Cube root, a to the 1/3 to the 3, that would be what? You multiply your power become 1, that would be 8, right? If we write a cube root of 8, take a 3 power, 3 times the triplet. Right. So square root of 8 actually is 2 to the cube, it will be 8. That means this inside, they are the same. That's how we use the symbol. That's why we say, okay, for the power, like this, 1 over some power is the same thing as you take the root. Okay? Just use a different symbol, but they actually mean the same thing. So it means what? If I write 1/3, that means I take a cube root of x. Okay, that's what it's talking about for this symbol. 1 over nth power means you take nth root. Okay? Then let's take a look with how do we simplify all the numbers. 16 to the 1/2 means what? Square root, right? That would be 4. Then if we do -4 to the half, that means what? Take a square root of 4, -4. Can we do that? We say for the even roots, inside you cannot have a negative number. It has what? To be positive or 0. So this one doesn't exist. Right? Then for -27 to the 1/3, it means what? Take a cube root of -27. For the r roots, we can use negative. You can take a negative out or you do it directly. It means what? -3 times itself 3 times, right? If 1/16 to the 1/4 power means what? 1/4 power means 4th root. But the 1/16 is real 1/16, a fraction, right? Then you take 4th root. That would be 1/2, right? If you have 0 to the 1/5 power, means what? 0, take a 5th root, that would be 0. Right? Got idea? Okay. Then for the numbers, we have, for the x's, we might have x to the 1/4 power. if you write the, radical styles, so that would be fourth root of x, right? If we have 81x to the 1/4 power, 1x power, let's see. Oh, that's 81x to the how many powers? 8 to the 1/4 power, 2 bases, right? You can distribute them, or you can just write the whole thing to take a fourth root, right? Then 81 take a fourth root would be what? 3, right? Then x8 take fourth root would be squared, right? Then if we have 5y to the how many powers? 1/3 power. So instead of writing the power styles, then you can write the 5y to the cube root, right? So we are saying is what? Radicals, and they are interchangeable to the what? Rational exponent form. Right? So they are actually interchangeable. Right? Then next one, we already talked about it. So we say am to the nth power is same thing as am, take a power first, then root second, right? Or we can take what? Root first, then power second. So this one is power first, then root second, right? Then this one will be what? You will take a root first and power second, right? They end up same thing. Okay? So what are we talking about? Rational exponents. That's what we are talking about. What kind of numbers they are. Or we'll write it in the x's. Same thing, you will handle it same way. Okay? Let's look at page 49. Try to make the numbers simpler. Okay? So if we have 64 to the 2/3, right? Top one is power, bottom one is the root. But if you take a power first, second power of 64, that's a big number. So instead of doing that, we usually do the root first. Make a number smaller, easier to handle, right? So third root of 64 is 4. 4 take a square, it's a 16. Okay? And if we have, especially if we have 64 to the 3/2, 64 take a 3 power, too big. Okay, so we do the root first, square root, then take a power. Square root of 64 is 8, take a 3 power. The number would be much easier. Okay, multiply 3 times. Right? Then if we have 32 to the -4/5, so if you have a negative power, you have to handle that first before you handle the fractions power, right? So you will do what? 1/32 to the 4/5. Then for the power, a rational exponent, we do what? Let's do the root first, if we can, fifth root, right? Then do the fourth power, okay? So 32, the fifth root, you do your trees, that would be 2, 5 times. To the fourth power, that would be what? 2, 2, 2, 2, 16, right? Okay. If you have negative 8 to the negative 2/3, okay, this negative 8 is the base. It's a real negative 8. It's different from what? The negative on the exponents. Okay? So you need to interpret this first. This one means what? Reciprocal. Right? So you will have what? 1 negative to the 2/3 power. If you write it this way, is that correct? Not really. Why? Because for the 2/3 power, the base is the whole thing is negative. Okay, that's a real negative number. So what you would do? Okay, so you do the cube root first for the root, then you take a power. Then cube root of 8, negative 8 is what? Negative 2. Same thing, that's the whole base. You need to put the whole base in the parentheses. Otherwise, the sign will not be correct, right? So negative 2 squared is what? 1/4. Otherwise, you will have a negative number in the denominator, which is not correct. Okay? Then you look at the next one to the 3/4 power. Same thing. Base is negative. So you do negative, take a 4th root, and take a 3 power. But for the even roots, can you have a negative number inside? No, you cannot. So it doesn't work. Right? So not a real number. Those are numbers. Then what happens if we do this way for the variable, okay, to the 3/5 power? How will we write it? So we write it this way, because 4x minus 1 is the whole base. You take a 3 powers, then you take a 5th root for it. If we write it in radical form, it will look like that. Okay? For next one, what's the difference between negative 4th power and x1 4th power? Sometimes you get confused. Oh, negative, I do what? Reciprocal. But reciprocal is for the whole base, not only for your power. Negative 4 means negative 4. 1/4 means 1/4. Each represent a different concept, right? Because they are symbols. Then for this one, that would be what? Negative means what? Reciprocal. It's 1 over x to the 4th power, right? And this one actually is x what? Power and the radical. So that's what? X to the 1 power, take a 4th root. They are totally different things. But somehow you will mingle the concepts of negative becomes 1/4 reciprocal. You don't do the reciprocal for the power. It's the whole thing, whole base together. Okay? Then for the D, we don't need to worry about that. Let's just skip it. Okay? So, what are we doing? Think about it. We are doing what? Rational exponents, right? And rational exponents are interchangeable with what? Radicals. Okay? Then when you go to calculus level, we just keep all the exponents. We don't change it to radicals. We just handle them directly with all the properties, right? We will with what? Product property, quotient property, power property, right? We do that, or we use the power of a quotient, power of a product to distribute your powers as well, okay? So we just use what? The power for the next one, we just use the power of exponents. We just talk about all those properties to simplify our exponents style, right? But ideally, we still want to write with the positive exponents because we don't see the negative exponents. Then if positive, at least we can see you multiply that thing 4 times, right? Negative 4 doesn't mean you multiply anything negative, right? So we want to simplify all those exponent things. We still do the same thing to simplify. What do? We don't want to have parentheses. Okay, you write it individually. Then we will use all the properties we have learned, right, for the exponents. Then we will consolidate the same base into one power with its own power. Not too many powers applied to just one base, right? That's how we simplify that. So if I have x 2/3 times x negative 2/3, what do you think? That would be what? Am times an equals what? Am plus n, right? You add your power. So you do 2/3 plus negative 2/3, which is what? X to the 0, right? But anything to the 0 power is 1. So that would be your answer as a simplified situation, right? If you have m half over m 1/5, so it's a division, so we use quotient property, 1/2 minus 1/5. Then what is 1/2 minus 1/5? Then you have to do your fraction with LCD. 10, right? Times 5, 5/10, then 2/10 times 2. So that would be what? 3/10. So you write m to the 3/10. You can just leave in the power form, exponents form. That would be fine. But we don't want to have a negative exponents. We always flip for those. Okay, let's take a look at the next one. If we have x4, x8 to the 1/4. Power on power, we use power property. A times 1/4 is 2, right? So that would be x squared. That would be the simplest form. Okay, right? Okay, let's see next one. So if we have 27 n to the what? 15th power n to the what? 11th power, then take 1/3. Okay, so 3 bases with power, we use what? ABN equals what? Power product. You distribute your power for each one, right? So you have 27 1/3 power, and 15 to the 1/3, and n11 to the 1/3, right? 27 to the 1/3 is what? Cube root of 27, right? Which would be 3. Then m 15 times 1/3, right? So 15 times 1/3 power on power property. N is what? 11 times 1/3, so that would be 3 n to the 5th power, n to the what? 11 times 1/3, you cannot simplify, you just multiply straight across. That would be what? 11/3, right? So what are we doing? We just simplify our powers and write the results as the positive exponents. That's what we want to do. Okay, look at the next one. If we have negative 27 and negative 12 n to the 3rd power to the over p to the 15 to the 1/3 whole thing, right? So for the 1/3 power, you have how many things inside? 1, 2, 3, 4. 4 things. Okay, so you need to distribute your power when you remove the parentheses for each individual base. So you have 27 to the 1/3, right? M negative 12 to the 1/3, N 3 to the 1/3, then P 15 to the 1/3. Is that right? Then negative 27 to the 1/3 is cube root. That's negative 3, right? Then here, power on power property. So you have to multiply your powers, right? So that would be what? Negative 3, m to the how many? Negative 4, right? N to the how many? 1, right? P to the how many? 5, right? But we don't like to leave the answer in negative exponents. So we need to flip them. Which one we need to flip? Only the one with negative exponents, right? So you will do what? Negative 3 n stays. So m to the 4th power, p 5th power stays. Is that right? That would be your simplified form. Okay? Let's look at the next one. If you have m times m to the negative 3/8 and m to the what? 1/6 times m to the negative 5/6. Too many powers, too many m's, consolidate them, right? So on the top, that will be what? M, this is the invisible one. Product property, use this one, will be 1 minus 8/3, right? Same thing on the bottom will be 1/6 plus negative 5/6, right? Then what do we have? 1 minus 8/3, do your math, okay? Would be 3 LCD minus 3 8/3, that would be negative 5 over 3, right? So that will be for the numerator. So you will have m to the negative 5/3. Is that right? The bottom. So 1/6 plus what? Negative 5/6 would be negative 4/6, right? So that will be your m, negative 4/6, right? Then it's quotient property. So you will do what? Negative 5/3 minus negative 4/6. Is that right? Be careful with your signs. So that will be negative 6/10. Negative become plus, will be 4/6, right? That would be what? Negative 10 plus 4, negative 6 to the 6. That would be what? Negative 1, right? So if you write this, that would be m negative 5/3 minus negative 4/6. Is that right? Quotient property, right? The top minus the bottom one for the powers. So you have what? Negative 5/3 minus negative 4/6. That would be negative 1. And we don't write the answer that way. We write in positive exponents. So that would be 1. Invisible 1, we don't have to write it. So it will be 1 over m. Right? So what are we doing? We are simplifying bunch exponents, right? Then finally write the answer in a positive exponent, that way. So that will be your section 9.8.